What's going on, electricians? In this video, I'm going to be answering a really tough voltage drop question you very well might see on your licensing exam. One of my viewers reached out to me and said, hey, I need help with this one. Can you show me your formula? And that's what we're here to do. Hopefully you enjoy this video. It says a 120 208 volt three-phase system feeds a detached building with a load of 24,960 volt amps using 1 gauge copper conductors. What is the maximum distance the feeder can be to not have a voltage drop of more than 5%? This is not a typical voltage drop question, but like I said, you very well might see this on your licensing exam. Okay, so for voltage drop, you need to be aware of the formulas. Okay, so the one that we're going to be utilizing today is voltage drop equals to kill over the circular mils of our wire. Now, what's super important to understand is that this is specific to single phase equations, okay, or installation. So for when it says 3-phase, we're going to take this 2 and exchange it for 1.732. Okay, so let's do that real quick. So voltage drop equals 1.732 times K times I times L over the circular mils. Okay, so now at this point what we usually do is start plugging in what we know and yeah, based on the information in the question. But let's identify that our question is asking us what is the maximum distance. So what we actually need to do is rearrange this formula so that instead of us solving for voltage drop, we're actually solving to get the length. So we have to use basic algebra, which I teach in my book in chapter 2. Probably, to rearrange this formula to get L, the length, by itself. But you know what? Before we do that, I'm just going to start plugging in what we know. Okay, so what's voltage drop? Voltage drop that it's telling us not to exceed is 5%. Okay, so 5% of what? 5% of the incoming voltage. Okay, so what's the incoming voltage? It's going to be 208 volts. Okay, and to figure out what 5% of that is, we're going to multiply that by 0.05. So let me get my calculator out. So 208 times 0.05, not 0.5, 0.05. Gives us 10.4. So my voltage drop that I can't exceed is 10.4, okay? My 1.732 is staying the same, obviously. The K is a constant that you should be aware of. They don't give you that information, and they just expect you to know it. So for copper, in our question, it says that it's copper conductors. Our K constant is 12.9, okay? Now, I is amperage. When we look in the question, we don't have amperage. It only gave us volt amps, 24,960. So what I'm going to do, I'm going to do the math over here. So 20, can you see that? 24,960 is our power. It's our volt amps, okay? So how do we use the information in our question, which is volt amps and volts 208, to solve for ampacity? Well, you should know that P equals I times E, right? That's the easiest Ohm's law formula. So this is my P equals I times E, which is 208 volts, okay? But remember, this is 3-phase, so it's actually times 1.732 as well. So now, just like what we're going to do up here, we have to get I by itself. So let's multiply 208 and 1.732. So 208 times 1.732 gives us, so I'm going to write I down here, times 360.256, okay? So now, 24,960 equals I times 360,256. Now, to get I by itself, we're going to divide by this same number, right? That would just give us 1. So these would cancel out. But what I do to one side of the equation, I have to do, or the equal sign, I have to do to the other side of that equal sign. So I need to take the 24,960 and divide it by 360.256, and that's going to give us our amperage. So 24,960 divided by 360.250 gives me an amperage of 69, and then a big decimal place. I do it to the nearest tenth, okay? So I'm going to round up to 0.29 equals my ampacity. So now I have my amperage. Now I can put it in my I formula, okay? So this is going to be 69.29 times L gives me the circular mils. Now, the question gave us that we're using 1 gauge copper conductors, right? So how do I figure out the circular mils of that wire? We need to go to Chapter 9, Table 8. So let me do that here. I'm using the 2026, but it is the same information in the 2023. Wow, I thought this would be quicker. Chapter 9, Table 5, Table 8. Here it is. Okay, so when we go to Chapter 9, Table 8, we can go to 1 gauge copper, and then we see circular mils is 83,690. Okay, so circular mils is 83,690. Okay, now we have all of these numbers. So the first thing that I'm going to do is I'm going to get rid of this denominator. How do I do that, okay? If it's divided by this number, I can multiply this whole side of the equation by 83,690. Hopefully you guys can see this. Now, when I do that, these two numbers cancel out, which is great, only leaving me my numerator. But remember, what I do to one side, which is multiplying 83,690, I have to do on the other side of that equal sign. So I'm going to rewrite this formula to 83,690 times 10.4, right? Now that's the left side of the equation, equals my entire numerator times L. Now, instead of rewriting all this out, I'm actually going to multiply these numbers together to give me one solid number, okay? So let's clear my calculator here. Come on, 1.732 multiplied by 12.9 multiplied by 69.29 gives me 1,548, and then I'm going to do 2 decimal places, which is 0.13 times L. Okay, so now I have a multiply here. Now, again, I'm getting L by itself, so what I'm going to do is I'm going to divide by 1,548.13. That cancels out this side, but remember, what I do to one side of the equal sign, I have to do on the other. So now I'm going to take this and divide it by 1,548.13. So now I'm going to simplify. Now I have this whole number. Okay, so 83,690 times 10.4 gives me 870,376. Now I'm going to take that number that's in my calculator and I'm going to divide it by 1,548.13, and that gives me 562. 562. It does say 0.21, but now since this is my final answer, I'm just going to round it to the nearest whole number. So 562 is going to be my final answer. Now, when I go to my my question, it was quiz 1, question 6 in the 2026 comprehensive guide. I see that C is exactly 562 feet. So quiz 1, question 6 is C, and again, there's no code article for this, it's just general knowledge. They just expect you to know that. Now, I only have 1 minute left of this video. I just want to explain, listen, if you get this question on your licensing exam, skip it. I just took 8 minutes to answer that question. Mind you, I'm teaching it and I know what I'm doing, but odds are it's going to take you even longer than 8 minutes to answer a question like this on your licensing exam. Again, just skip it. Just skip the question, move on. At the end of the day, it's all multiple choice. You have a 25% chance of getting it right. Just skip it, save it for later. If you have time, then you can take your time and see if you can calculate the answer just like I did. But again, these videos are designed to help you gain the confidence so that you don't have to waste time, you don't have to feel the stress. You're going to know exactly what you need to do to find the answer. So comment down below if you learned something. If you have any questions, we're here to bring clarity to electricians to help you pass your next electrical licensing exam. Thanks, guys.